Now, this is our introductory lesson to calculus, and what we're going to do as part of this start of activity is to find the slope or gradient at certain points on a curved line. Now, I've drawn the first part of y equals x squared here, which ideally you should do by doing a table of values, plotting a few points, and drawing a smooth curve through. And what you can see is that the slope is gradually increasing and increasing. So we can see it's certainly not as easy as doing a straight line graph where it's like 2x plus 1, you can say the slope's always 2. You can see that it's changing here. So what we did to try and find this is, I suggested drawing a tangent. Now remember, a tangent is a point that only touches, a line that only touches at one point. So my curve carries on through here, and this line hopefully just touches at a single point here. And we're going to repeat that at x equals 2 by drawing another tangent and x equals 3. Now I already have those prepared, so let's take a little look at what it looks like. So if I was to, I'm going to change the scale on here so you can see the graph a little bit clearer. Here's my tangent just touching at a single point. I went through 1, 1 and 4, 7, and I tried to pick 2 points that are quite far apart so we can see accurately what the slope's going to be. So using my slope formula, I can find that it's 2. Or you can simply just count squares as well. Rise over run, so rise is 6, run of 3, 6 divided by 3 is 2. So the slope at x equals 1 for y equals x squared is 2. Now if we do that for another point at x equals 2, so I'm going to say this touches that point just at one single point there. I can take 2 points on the line. I tried to choose 2 points that are a long way apart again. And you can see if I do the calculation here that we get 4. Or you could do rise over run again and also find that it's 4. And I did this for one more value when x equals 3. So at this point here, I tried to make this line touch at one point. Very difficult to do accurately, but I did the best that I could for this one. And I took 2 points that lie on the line, and I had to guess on this one what it was going to be. But when I substituted the numbers in, I found that it was 6. And also rise over run 12 over 2 is 6. So for the graph y equals x squared, what we notice is at x equals 1, the slope is 2. At x equals 2, the slope is 4. And at x equals 3, the slope is 6. And then hopefully from that you should be able to figure out what the rule actually is for this. So basically whatever the x value is, if we double it, that will tell us what the slope is at that point. So what we can say is the slope for y equals x squared is 2x. And then we simply plug in the value of x that we actually need. Now, what are some of the problems with that method? Well, certainly drawing a graph is time consuming. Finding an accurate tangent, if you've actually tried this exercise by hand, is also very difficult, and you're not going to get the exact values that I had. And if I pick another shape or another equation, you've got to redraw that, and it can be very troublesome. So we're going to look for something as an improvement on that. Let's take a look at this graph here. Now, I've redrawn my graph, and I've redrawn my tangent. And what I've done is I've drawn a line connecting the point to this point up here. And what you can see here is this is actually a very poor approximation for what the tangent is supposed to be. However, if I bring the point a little closer, instead of going as far away as 4 on the curve, if I go to just 3 on the curve and draw the line, I'm still not very close to the tangent, but you can certainly see it's an improvement than 1 to 4. And then we can just keep extending that idea. So this time, instead of going 1 to 3, I can also look at 1 to 2. So still not really the slope that I'm looking for, but certainly a lot better. So as we get closer and closer, the 2 points together, we get a better and better approximation for this tangent. And if I go to 1.5, then you can actually see this is starting to get a lot better. So if we were to keep doing that, and very difficult to draw on a graph, if I was to choose 2 points very close together, then in theory they would actually make that line there. So, if I want 2 points to be as close together as possible, what I can actually choose is 2 such points. So I can choose 1, 1, and then just a tiny little bit to the right, 1.01. And if I substitute that x value into that formula, I can find out what the appropriate y value is. If I plug them into the formula for slope, what I actually end up with is 2.01. Now remember, the actual slope we figured out was 2, so very good approximation if we choose 2 points very close to each other. Now you can also do the same thing by choosing 2 points the opposite side. Choose the point itself and one to the left. And if we do that, so just a little bit to the left, 0.99, if you plug that in, then what you can see is 1.99. So what we have here is what we call a limit. So if we go to the left, we can see the value is 1.99. If we go to the right, it's 2.01. And we're sort of squashing these values to try and find what the actual value is. So using a little common sense for this, we can figure out that the slope actually is 2 with a little bit of rounding. So that's actually one other way we can actually find out what slope is as well for curve points. Choose 2 points on the line that are very, very close together. Use the formula for slope. Check either side, and then we can hopefully use a common sense approach to figure out what the actual slope of the tangent is. And we'll look at a more definitive method next. Now, both of those two previous methods that we looked at, the first one of drawing a graph and then drawing a tangent and finding the slope of that, and also finding 2 points that are very close together and then find the slope from that, both work, but they're both very cumbersome. So we're actually going to look at a slightly better method. We're actually going to look at a proof of why these actually work. So let's go back to our original equation, which is y equals x squared. Now, the 2 points that lie on that line, we're going to have an x value and then its associated y value. But notice to find the y value, what we do is we take the x value and we square it. So this is actually going to find as a rule for every single point, rather than just trying to find a rule for like when x equals 1 or x equals 2. We're going to find it for any single value of x. Now, here's where some of the calculus comes in. We want to choose two values that are very close to each other. So this little symbol here, delta, means a very small value. So I'm going to call this x plus delta x. And then to find the associated y value, what I'm going to do is I'm going to square what my x value is. So in other words, I'm going to do x plus delta x squared. Now, think about what we actually did when we were finding the slope. What we did is we took the 2 points, we plugged them into our formula, and that's exactly what we're going to do here. To find slope, we're going to do y2 minus y1 over x2 minus x1, but for the points that we have here. So this is our x1, this is our y1, this is x2, and this is y2. And I'm just going to substitute those into this formula. So on the top here, I've got x plus delta x squared minus y1, which is x squared, all divided by x2 minus x1, so x plus delta x, and take away x. Now when I come to simplify this, one thing I can see straight away, x take away x is going to cancel, so I'm just going to get left with delta x on the bottom here, that small change in x. Now if I do FOIL on the top here, I'm going to get x squared plus x delta x plus another x delta x, which is 2x delta x, plus delta x times delta x, which is delta x squared. And just like that, very clear. I'm going to put parentheses around there, so I'm not doing the delta of x squared, I'm doing the delta of x, and I'm squaring that value, minus x squared. Now actually, I can do the same sort of thing with this as well, because I've got x squared take away x squared here. So if I get rid of those, then I've actually got a little bit simpler equation to look at. Because this is positive 2, I'm just going to get rid of that as well. Now, the thing I notice here is also every term I have here has a delta x in there. So if I divide throughout by delta x, and I'm going to work this way now, so 2x delta x divided by delta x is 2x. Delta x divided by delta x is just delta x. And delta x divided by delta x, anything divided by itself is just going to give me 1. So as we're dividing by 1 here, that doesn't really do anything, so all I have here is 2x plus delta x. Now remember what the definition for this was. Delta x is a very small value, and we saw as closer as we've got those 2 points, the more accurate the answer. So really what we want this to be is 0. So if we have the 2 points right next to each other, or literally on top of each other, then we have the perfect answer to our slope. So as delta x, what we say is as delta x tends to 0, so as this gets closer and closer to 0, this is basically 0 now. So our answer is 2x. And that's actually what we found a few moments ago when we plugged in our numbers. So when we times by 1, we got a slope of 2. When x was 2, we found the slope was 4. When x was 3, we found the slope was 6. We were just simply doubling. So that's the formal proof of this, and this is called by first principles. So this is how we can actually go ahead and find all our rules for sure. What you'll be pleased to know is, as true as this is, there's an even quicker way where we can find out just what the rule is. But this is the proof of why that rule actually works. So as a little sneak preview actually for next lesson, just so you can see what's actually going to happen and to see how quick this is going to become, what we found out was when y equals x squared, our slope, what we actually call it is, we call it dy by dx. So we looked at the difference in the y values over the difference in the x values. That's your y2 minus y1, x2 minus x1. So it's another way of writing that. Also, d is very similar to that symbol for delta as well. So another reason why we choose that. Now, what this process is you've actually done here is called, this is actually called differentiating. So if we're given an equation and we want to find a formula for its slope, then we say we have differentiated. And this would be our first derivative, this property here. And what we actually do is when we differentiate something, we bring the power to the front, and then we decrease the power by 1. So in other words, you can see it's just 2x. So if I wanted to do x cubed, think about all the steps we had to do to prove this. I could actually do this question very simply. If I was asked to differentiate x cubed, so dy by dx, bring the power to the front, and then decrease the power by 1. So a general rule for this would be, if we have ax to the power of n, then our derivative, bring the power to the front, and n times a is just an. X to the power of, decrease the power by 1, n minus 1. We're going to look at that in a lot more detail in the next lesson.